So for 10D, we look for GCF, and there is one other than 1. That would be 2. So that gives you 64y cubed minus 125. And this factor right here, the binomial, is a difference of cubes. So the cube root of 64 is 4. The cube root of y cubed is y. Cube root of 125 is 5. Okay? So you bring down the 2. For y, the first in the binomial, it's the same sign. And then in the trinomial, you square the first term, so that gives you 16. This is just another strategy. Then you multiply the 4 and the two terms, the two binomials, so that gives you 20. And when you multiply these two, this one and this one, that gives you 20y. And it's the opposite sign, so that's now a plus. And then for the third term, you square the second term in the binomial, so that's 25, and it's always positive. So that would be the factored form of letter D. For letter E, we look for a GCF first, and again, it's 2. So you factor out a 2, so you get 3x cubed. So then that's 3x cubed on the first term, and then minus x squared minus 3x plus 1. Okay, now it's 4 terms, so I'm going to see if it factors by grouping by making the 2 by 2. So I just put the terms in order as I see, in descending order, so it's like this. Greatest common factor in the first row is x squared, and so 3x times x squared is 3x cubed, and then negative 1 right here, and then negative 1 right here. And so I check, is negative 1 times negative 1 equal to positive 1? Yes, so then I factored it correctly. So here's what I have. I've got 2 times x squared minus 1 times 3x minus 1. This here is difference of squares, so you have to factor it further. So that's x plus 1, x minus 1. And so that's the factored form. For F, I noticed that the first term and the last one are perfect squares. This one and this one are perfect squares. So I checked to see if it's a perfect square trinomial. Square root of 16x squared is 4x. Square root of 1 is 1. And then I check, is 4x times, what's 4x times 1? Well, it's 4x. When you double it, does it give you 8? Yes, it does. So then it is a perfect square trinomial. All you do is you bring down the negative, and why? Because that's the coefficient of the middle term right there. And then put in parentheses, squared. Okay, so first they want you to identify the transformations from f of x to g of x. So it starts off as a parent function quadratic, a parabola. And so here is the g of x, a transformed function. So this 2 right here is a vertical stretch by a factor of 2. This negative is a reflection over the x-axis. This 3 is translated to the right 3 units, positive to the right, and this one, this negative 1, is translated down 1 unit. So the reference points for a quadratic are, and I'll put them right here, negative 1, 1, 0, 0, 1, 1. Okay, so the h is 3. That affects the x coordinates. So x plus 3. And then the a is negative 2 and the k is negative 1. That affects the y coordinate. So negative 2y minus 1. Okay, so now I'm going to transform the 3 points. So negative 1 plus 3 is 2. Negative 2 minus 1 is negative 3. 0 plus 3 is 3. 0 minus 1 is negative 1. And finally, 1 plus 3 is 4. And negative 2 minus 1 is negative 3. I'm going to plot those 3 points. Okay, so there are the 3 points right here. 2, negative 3. 3, negative 1, and 4, negative 2. So now we're just going to connect them. Remember, it's a parabola. So it goes something like this. For letter B, the transformations are that there's a vertical compression by a factor of 1/2. It's translated to the left 1 unit and up 3 units. So the reference points for a cube function are -1, -1, 0, 0, 1, 1. And then just for extra measure, we put in 2, 8, just to make sure you guys graph the right thing, the right function. Okay, so let's see, the x's get transformed by subtracting 1, so x minus 1. The y's get multiplied by 1/2, and then added 3. Okay, so 2 things. So let me just draw the arrows that connect. So -1 minus 1 is -2. -1/2, I'm sorry, -1 times 1/2 is -1/2 plus 3, that's 2.5. 0 minus 1 is -1, and then this is 3. 1 minus 1 is 0, and then 1/2, that's 3.5. And then 2 minus 1 is 1. Half of 8 is 4, 4 plus 3 is 7. Okay, so now we're going to plot the points. So -2, 2.5, about here. -1, 3. About here. 0, 3.5. About here. And then 1, 7. So it goes something like this. And let's see. Like this. Okay, so the inflection point is this one right here. This is, let me change the color. -1, 3. That's the point where it changes direction. Alright, so for letter C, you have a cube root function. The transformations are vertical stretched by a factor of 2, translated to the right 1 unit, and up 2 units. The reference points for a cube root function are just like the ones for a cube function, except for the fourth, the first 3 are the same. So -1, -1, 0, 0, 1, 1, and this time it's 8, 2, because remember these are inverses, the cube root and the cube are inverses of each other. So I'm going to add 1 to the x's, x plus 1, and the y's get multiplied by 2 and then add 2. So let me get the points like this. So -1 plus 1 is 0. 2 times -1, -2, plus 2 is 0. 0 plus 1 is 1. And then this gives you 2. 1 plus 1 is 2. 2 times 1 is 2, plus 1 is 4. 8 plus 1 is 9. 2 times 2 is 4. 4 plus 2 is 6. So this is what we're going to plot. So 0, 0, 1, 2, 2, 4, and 9, 8. So 9, about here. Okay? The inflection point, remember, is this one. So I'm going to change the color so it stands out. And the graph goes something like this. And like that. For letter D, there's a vertical stretch by a factor of 3. And the negative here says that there's a reflection over the x-axis. And then this one, notice it's outside of the radical. So that means that there's a translation up by 1 unit. Okay, so the reference points for a square root function are 0, 0, 1, 1, and 4, 2. You have to start right there. Okay, this is the dot. you have to start on 0, 0. Now, the transformations here, I'll make in green. It's going to be h is 0, so nothing changes. And there's no b is 1, so again, the x stays the same, but the y is negative 3y plus 1. Okay, so x's don't change, so it's 0. Negative 3 times 0 is 0, plus 1 is 1. The 1 doesn't change. 1 times negative 3, plus 1 is negative 2. 4 doesn't change. And then negative 3 times 2, negative 6, plus 1 is negative 5. Okay? So now I'm going to plot the graph, 0, 1, 1, negative 2, and 4, negative 5. Okay, so remember 0, 0, which is now 0, 1, that's your dot. Okay, there should not be an arrow on that end. So it goes down like this, like that. The arrow goes at the bottom. So 12, it says identify rational zeros and then write the function in factored form. So first thing I tried is to see if it factored by grouping, and it doesn't. So I can't use a little box or the pairing them up and grouping them together. So I am going to have to do the p's over q's. So in this case, the p is plus or minus 1 and plus or minus 5. The q is plus or minus 1. Okay, so p over q is, since q is just plus or minus 1, p over q is actually this list right here. Plus or minus 1, plus or minus 5. And you pick from that list to divide. So I'll start with 1. 1, negative 7, and again, synthetic division. So, and remember, we're looking for 0. So you bring down the 1. 1 times 1 is 1. Combine. 1 times negative 6 is negative 6. Combine. And then 1 times 5 is 5. And we got lucky. We got a 0. So that's going to work. Now remember what these three numbers mean. This means x squared minus 6x plus 5. And the one that I circled in synthetic division, that means that the factor was x minus 1. Okay? So, factors of 5 that add up to negative 6, negative 1, and negative 5. And so I could factor this as x minus 1, x minus 5. Notice I have two of those, so f of x could be rewritten as x minus 1 squared, and then x minus 5. So that's the factored form. And the rational zeros would be 1 and 5. So factors, again, letter B does not factor by grouping. So the p value